Hello, hi. Let's talk about 3D modeling workflows, and specifically CAD modeling workflows. So typically when you begin your CAD design, you're quite restricted in terms of what you can do with the form, because you operate within a very specific set of CAD commands, right? You have your booleans, your trims, your fillets, your blends, and your extrusions. And all of this makes the early stage of the sketching process quite restrictive. So what I want to offer in this video is this different approach to an early stage sketching process, design process if you will. And it's definitely a more messy approach, but something that gives you more the benefit of more creative freedom. And before we jump into it, let me just show you my workspace. All right, so here we go. We have ourselves, get out of the way. We have ourselves a 3-monitor setup. And since the laptop has its monitor always turned off because it's an OLED screen and we don't want any burn-ins, it's a 2-monitor setup. And one of the monitors is actually an XP Pen 22-inch graphics tablet. I'll leave a link to it in the video description. It's literally a 1-monitor setup plus a graphics tablet. And for this particular tutorial, I will be using a graphics tablet. That's why I'm showing it to you. Simply because it makes the whole process quite easier and much faster. Can you do it with a mouse and a keyboard and a single proper screen? Yes, absolutely you can, but using a graphics tablet for something like this just speeds up the process quite a bit, right? And I will be talking about what kind of tablet would I suggest you get and so on throughout this video, right? But don't be scared if you don't have it, you can still follow along quite easily. Okay, let's jump into it actually. Oh, and I forgot to mention, for this we will be using Blender, so link in the video description below to download Blender, and the early stage is going to be us messing around with Blender, and then we will be jumping right into Rhino as our CAD software. So download Blender before we begin. Let's go. All right, so our starting setup is pretty straightforward, right? We use the tablet as a screen and we use keyboard and mouse to make the first adjustments to the geometry, right? And well, I guess what kind of adjustments do you make depends on what kind of geometry are you trying to achieve, and that depends on what you're trying to design. So I'm aiming for, let's go for a helmet design, a full-on mask plus head cover helmet, right? So we start always by hitting the A button to select everything and deleting everything in the scene. So A, delete, and then hitting Shift A to create a new mesh. And for a helmet, you can either use a cube or a sphere. In this case, I will be creating a cube and then I will be subdividing it into a sphere. And as you can see, I'm still using this tablet as a, just a proper monitor, right? So cube gets created. While I have this cube selected, I click on this little modifiers icon right here, the little wrench icon on the right hand side, add the modifier, and I add a subdivision surface modifier onto the cube. Every surface becomes 4 surfaces, or every quad becomes 4 quads, and also the corner vertices get smoothed out, right? So you're basically increasing the amount of polygons 4 times with every subdivision level, and also you're smoothing it out. So a cube becomes a sphere. This is after 1 subdivision. We need more, so here under levels of viewport, I will just click on this little icon right here to add more levels of subdivision. I guess we can do 4. 4 levels should be good enough for the starting kind of trying out the shape level of work. So after this is done, we need to apply the modifier, and to do so you just click on this little arrow here next to the X sign and hit apply, or Control A. You can also apply it with Control A. Okay, once this is done, this was short, but this is basically where we end the keyboard and mouse workflow, and then we enter the pen and tablet workflow. And then after the sculpting is done, we will come back to keyboard and mouse. Can you do the sculpting with keyboard and mouse workflow? Absolutely you can, but pen and tablet is just, in my opinion, superior. It's just better to sculpt with. Okay, so I'm just going to move this away. I'm going to show you. Okay, so let's switch here. So there's this lever here. By the way, this is pretty damn heavy, right? So we have this lever here, and if let me put it there, and if I hold it down, I can now tilt the whole screen to be, more horizontal. So that's a nice little adjustment mechanism. Hello, dial. There we go. So I can use the dial to zoom in, zoom out, and there's like different keyboard keys that I have remapped to this little keyboard here, so that I don't even need to use my own keyboard. Some people prefer to use their keyboards, some people prefer to use these. I prefer to use this. It's just nice to have like a small little keyboard here. Back to the tutorial. So under the mode, I switch from object mode to sculpting mode, right? And these are all of the different tools in terms of sculpting that we have. We will not be using many of them, just some. And always at the start, try to have your resolution as low as possible. And also one more thing is, since we're dealing with a symmetrical shape, I will turn on symmetry for this. So here in the top right corner, we have X, Y, Z symmetry, and I'll just turn on the X symmetry. Now as I drag my mouse or my pen on the surface, you can see that it's mapped to the other side as well. I can even draw a little bit so that you see better, right? Like that. Okay, let me undo real quickly. So that's basically that's basically how it works. Then in terms of the preview itself, one thing that I like to do is go here into top right corner and instead of choosing studio lighting, I prefer to use matcap. Matcap just gives an more contrasting light that accentuates the shape so that you can clearly see what's going on with your form, right? So once this is done, you are kind of ready to go. So the first thing is to always use the elastic deform tool, this one right here, and to just stretch on the form, right? So to make it bigger or smaller, in terms of proportion, sorry. Should have said that earlier, in terms of proportion, right? So we're dealing with helmet design, so I'm just going to stretch it out like so. Then perhaps we zoom out a bit. We scooch it like that. Yeah, something like this. The forehead can come up like that. Maybe this goes here. And all you're doing right now is just playing around with the, let's make it smaller. You're playing around with the proportion and trying to get some sort of a idea of the silhouette of the shape, going. Okay, so in just a few kind of quick little strokes, we have something that looks almost like a mannequin skull. After this is done, this is where it starts getting a little bit more interesting, because you can actually start, making ideas or creating ideas on the shape in terms of the form, right? So I'm going to use clay strips for this. You can either use just the regular draw tool or the clay strips tool. I personally prefer the clay strips tool, and this is how it works, right? And I like to start with a really strong strength something like strength of 2 and just bulk out the basic form, right? The basic silhouette. So create a little bit more visual interest over the silhouette, right? Something like that. Apologies. Something like that. If you're holding the Shift key, your brush becomes a smooth brush, right? So that's very helpful in terms of cleaning up the definition a bit. Something like that. Then let's add more clay strips, perhaps here. Perhaps the chin line is, whoa, not like that. Perhaps the chin line is a little bit stronger here, like so. And then it connects to here, and that's gonna be pretty thick, like that. Yeah, something like that. And then we smooth out a few bits and pieces there. Okay, so this is still pretty low resolution, right? So at a certain point, you won't have enough polygons to work with, and you will want to add a few more polygons. To do so, all you need to do is just add a modifier, right? So we add a subdivision surface modifier. Well, not really. Instead of subdivision surface, at this stage, I would suggest adding a multi-resolution modifier. The multi-resolution modifier enables you to jump between resolutions rather than always going up. So you can go down in terms of resolution as well when you're using this, right? So here, you just need to click on subdivide once, and you can see your sculpt gets subdivided and your render or the preview gets subdivided as well, right? So now you have 4 times more polygons yet again, and you can continue using the sculpting tools to get even more definition in your helmet design. So let me just quickly do that. Okay, so an important thing to note is that at a certain point, it's going to become, just using the brush and smooth, it's going to make the objects too organic, it's going to be a little bit too blobby. And to combat this, what we use is we use 2 tools. We use the scrape tool, this one right here, and we use the flatten tool, right? So let me show both of them how they work. So in terms of the scrape tool, we always increase the strength up to 1. And then we just hit certain areas which we want to be flat. For instance, this bottom part right here. One more thing before I actually start flattening everything out, I kind of want to either increase the resolution even further of the multi-rise, or I want to remesh the whole thing. So it depends on what kind of topology you're after. The multi-res usually has a clean topology, while remeshing produces, you know, it's still voxelized, so it's still clean, but could be better. In our case, since we're going to be remaking everything by hand into a CAD file, we don't care about topology. So I'm just going to apply. Oops. You can't apply. Wait 1 second. Let's go back to object mode. Yes. The viewport, let's increase the subdivisions in the viewport up to 2 and then hit apply, and then go back into the sculpting mode. I forgot that you need to increase the viewport subdivisions. So after this is done, we can just hit on the remesh button like so. And here you can just choose the voxel size. Let me show you the default values, how those work. So remesh, hit OK. This is how it looks like with 0.1 resolution. Not that great. So let me undo this and let me go to remesh, and instead of 0.1 let's use 0.02, something like that. Hit remesh. It's gonna take a little bit longer, we're gonna have more polygons here and it's gonna be slower, but now we have much more resolution to work with. At this stage you don't want to have too many polygons, but also you kind of start wanting to have polygons in places where they really matter. Okay, so now it's time to scrape, right? And we start with a bit of a bigger brush, and we're just hitting it at certain angles, trying to catch those angles. So for instance, the bottom of the chin here, like that, we just flatten that out, hit that, let's zoom into it actually. Zoom in and also drag it here, hit that, right? So you can see how we're slowly defining areas, right? Or defining surfaces rather. In doing so, like that. This could be a bigger brush and we just hit it like so, and maybe it just tapers out there. Like that. Okay. This one does its thing. So I'm going to go around. I mean, there's no trick to this. You just kind of go around and try different things until it works. So I'm just going to do that for a little while. Give me a second. Okay, so for this kind of a quick then dirty tutorial, this should be good enough in terms of getting the definition going. I will show you the last two bits that I use. One is how to sharpen everything up, and the second one is how to add divisions for paneling. So the first one is sharpening everything up. Well, that's pretty simple. That is called pinch, the pinch tool. Before we use the pinch tool, I kind of want to remesh this whole thing again. So I'll just go for remesh. We can also use dynamic topology at this stage. Well, actually, let me use this as a in terms of good timing to showcase the dynamic topology. So if I have this tick marked, you can see that, let's look at this for instance. You can see that as I'm dragging my mouse or my pen along the geometry, it gets more pixelated, right? So it's dynamically remeshing the surface of the mesh. Let me do that again. It's dynamically remeshing the surface of the mesh according to some sort of predetermined value. And you can change those values by going here to dynamic topology and choosing the detail size. In this case, it's using the screen resolution to determine the size of the polygons, and it's using pixels, basically how big they are. So the smaller this number, the smaller the polygons, and I can show you. So instead of 12, let's go for 4 pixels. And now if I use the same approach here, you can see that the detail level is much higher, right? But instead of this, I prefer to use, instead of relative detail, I prefer to use brush detail and then change the percentage of the size of the brush. So let's say with 25, you can see that how do you call this, the amount of polygons basically is similar to 4 pixels in my case. But if I were to now go in here and then change this to, like, let's see, 50%, much bigger. If I go in here and change this to 12%, much smaller. And it's hard to see how small they get, but they're pretty small. But the nice thing about this, the polygons I mean, the nice thing about this is that if I increase the brush size, the polygons actually become slightly bigger because it's all controlled according to the brush. And now finally I can talk about, what the pinch actually does. It takes the polygons in the area and it tries to find creases. It tries to find corners towards which it can pinch. And for this I prefer to always use larger strength and just kind of go around my model, pinching it. Getting it all in place, making it nicer and clean. And you can see now I made the brush a little bit too small and it made so many polygons that I don't even know what to do with all those polygons that are made. But yeah, pinch is such a strong tool when it comes down to sculpting for hard surface modeling. It's crazy how much detail you can get, right? And how much cleaner the overall shape starts looking after you just get all of those gnarly polygons in line. So while I'm doing this, now I can talk about the need for a tablet for a designer. I believe that as you are creating something more complicated, something more complex, or something that requires more organic approach to design, such as this helmet or whatever have you, right? A tablet becomes quite necessary, quite essential, because it's we suck with mouse, right? Modeling with mouse and so on. It's much less intuitive than just simply drawing with the tablet. So do I suggest designers using or having tablets? Absolutely I do. And I think that's not a hot take, so to say, because tablets are quite popular amongst designers already. Do I suggest using a 22-inch tablet as an architect or like an object designer? I believe that comes down to preference, right? So if you travel a lot, if you need the tablet in various different places or areas, then 22-inch is too big. You can get away with something that is much smaller, right? But if you, that's a nice little crease. But if you only work in the studio and you only have your tablet in the studio, then I believe a 22-inch tablet is actually a very, very good value for money, because it also can work as a, sure, why not? It also can work as a screen, right? So you just use it as a monitor as well, because, for instance, this one, right? The Artist 22-inch, it's 120% Adobe RGB, has 120% Adobe RGB coverage, meaning that it's color accurate and it's good enough for any kind of web-based design work, right? Meaning that as a screen, that's great. And in terms of brightness, it's not the brightest thing ever, especially compared to, like modern OLED screens and whatnot. But it of course depends on your setup. For me, I just have blinds, and if I need to, I just put those down, right? So that's one thing that I would like to suggest to you, just thinking about if you need the tablet only in your office, or are you planning on using that on the road, so to say? If it's on the road, get a smaller one for sure, because also it's the weight that is a little bit problematic with a 22-inch. I believe it's, yeah, I'd say it's around 4 kilograms. So it's heavier than a laptop by far, like by a lot, much heavier. So make sure that you know, get the tool that's most useful for you. Okay, we're almost done with the creases. I think I will. Should I skip ahead? Should I speed it up? Not sure. Yeah, let me speed it up. One thing that I always suggest you do when sculpting is don't be afraid of attacking your sculpt midway, because it's not necessary for this to be done in one sitting, right? So what we can do is we can come in here and say, well, actually this ribbon right here is a little bit annoying, a little bit not nice, so I'm going to just make a hole here, maybe make another one perhaps here, something like that. Then take my flattening brush, create these kind of divots, flat divots, figure something out here and see if that looks nicer or not. Right, so never be afraid of just sacrificing the geometry in search of something that might be a little bit more interesting. Okay, let's do some paneling, because I could just spend hours on this, and we don't have, well, you don't want to sit here for hours just looking at me brushing away, right? Also, in terms of the workflow, because this is much more of a workflow style video rather than a direct tutorial on how to achieve a certain thing. In terms of the workflow, yeah, that's better. Try modeling something like this in a CAD software, right? That would be quite painful, and that would take quite a long time. So I believe that it being quite painful to model this kind of stuff out prevents us from even trying. So it's a good thing to sometimes switch up the way we approach things, the way we approach modeling. Okay, last thing, paneling. So in terms of paneling, we have this crease tool right here, crease, which goes into the negative, right? So if I just show it to you really quickly, that's how it goes, right? It creates a crease. That's the crease tool. Let me just undo it real quick. There we go. So for the crease tool, we want a few things. First of all, for the dynamic topology will adjust later. First, we adjust the size to perhaps something like this. Let's take a look. Yep, that should do the trick. Then we adjust the strength to in between 1 and 2, 1.5. 1.5 should be a good Yeah, that's pretty decent. Then we adjust the brush, sorry, not the brush, the stroke stabilization. So stabilize stroke. What this does, it basically, you know, in Photoshop where we have the stabilized stroke, that's exactly the same thing. As you're dragging, this red mouse, or not, red line appears, and then you can use that line to make, you know, pretty sharp turns, right? So that's one more thing. And the last thing is the dynamic topology. So the detail percentage is all over the place. I think we need it to be higher. Let's try with this. Yeah, that's a little bit better. For the stroke, maybe the spacing could be a little bit less. Let's see. Yeah, the 5% spacing seems to be doing just fine. I'll change the strength to 1 and I'll change the radius to a little bit lower, something like 8 pixels, and then I will use this to draw a few panels. So what you want to do is you want this you know, clay object to be divided up, right? So we need to find areas where panels can be made. So I tend to always start from the back, somewhere here, and I'll just draw real quickly. And in this at this stage we don't zoom in, zoom out. So you choose one particular zoom level and you don't mess with it, right? So let's try something like maybe from here. So something like this. It goes in, then perhaps it can go a little bit closer still. Oops. If you lose it, you can just keep going from where you left off. It doesn't need to be, you know, perfectly pretty. Something like that. Goes in. Maybe we can do like that. Then attack it here and finish it up going in here. Okay, so that's kind of one panel that might also get divided up here, like so. Okay, from that panel we go out here, that, maybe break it there, even further out, go back in here and make a long run until here, and maybe we can finish it up like so at one point. There we go. Then from here, panel can just go in here. I'm left-handed, so this is a little bit tricky for me. Something like that. Divides it up in half, goes around the perimeter here, like so. Well, that went away, but that's fine. We can always go back in here and fix it up. Okay, so if this opens up here, removes here, you're basically thinking about how does this work, where does it open, how does it get removed, right? Something like that. Is it time for me to speed it up? I guess it's time. Okay, and this is actually the part where we stop, where I say this is at a good enough level. Let me just do one last little bit here. Just smooth this one out. Scrape, scrape, scrape. Yeah, good enough. Okay, so that's how our little helmet looks like right now. Nothing spectacular, and you can push out a lot of these designs quite quickly in this kind of a organic modeling way. That's the benefit of this workflow, you know, using the actual tablet. And this is where we stop using the tablet, right? This is where we will actually go forward with the CAD design, which is going to be the next part. So for us to actually migrate this model into Rhino, all I need to do is just, well, first of all, I guess we should remesh this so that it's a little bit more manageable. So let's go for remesh. I'm using 0.01 meters for my remesh scale. For some reason I can't. Oh yeah, you can't remesh if dynamic topology is turned on. So let me untick that. And now remesh with 0.01. This will just eliminate, yeah, you can see that it locks down the resolution of our mesh to a specific value. And it seems like 0.01 might have been a little bit too much. So let me undo that. Let's try again with maybe half of that, so 0.005 remesh. The scale doesn't really matter at this stage. All that matters is proportion and how we have our seams laid out. So you can see that also we here have used only a few of the tools. There's plenty of really interesting tools available here, but for sketching this kind of a spherical or you know, enclosed shape based forms, you don't really need that many tools. All right, so this is done. This is remeshed, seems to be quite good. So now we go for our object mode, file, save as. You can just save your blend file, and then file, export, and we export it as either an FBX, OBJ, or 3ds. Well, in this case, there's no 3ds, so FBX or OBJ. I personally prefer to export as FBX simply because if you're exporting into Unreal Engine, for instance, then it needs to be actually FBX for it to work properly. Okay, and let me, helm.fbx, nothing really that needs to be changed here. Yeah, export it. And that's it. And that's done. So now I'm gonna go and sleep, and tomorrow in the morning we're going to, well, for you it's gonna be just like that, but we're going to start working on the CAD portion of this. In terms of final thoughts about the tablet workflow and so on, I do suggest at least checking out this kind of tablet, you know, the screen substitute large scale tablet, because over the course of a month now, this has been a very, very useful tool for me. So yeah, I'll leave a link to the tablet in the video description below. I do recommend using stuff from XP Pen. Okay, so now on to a more structured part of this video. What we're going to do is we're going to first import, of course, our helmet into Rhino. So I'm just going to choose import I believe it's on the desktop. Yeah, there we go. That's the FBX. And here in terms of the settings, well, we don't really have lights or cameras, so you don't really need to have these either ticked or unticked, it doesn't matter. The mapping, they kind of keep switching it around, so I tend to have this unticked. And then if I need to, I just rotate it in place. So I'll just hit OK. Rhino units, the units don't matter. We're going to scale the helmet to fit a certain size afterwards. So no, don't scale. Wait for it for a little bit and eventually it's going to, yep, there we go. It's going to import. The mesh is pretty damn heavy. As you can see, these are all of the edges of the mesh, and that's due to our remeshing that we have done on this shape. So what you can do is actually run reduce mesh command on this, and instead of 2 million polygons, we kind of want to have something closer to maybe half of that, 900,000. So 56%. Hit OK. Give it a second. This took around 1 or 2 minutes to reduce, and now if I unselect my mesh, you can still see that it's fully black, but now at least the density of the polygons is not completely obnoxious. Honestly, it still kind of is, so I'm going to hit it with a reduce once again. Reduce mesh. This time it's going to be much faster, and I think we're going to stick to, let's go for 250,000 polygons, something like that. Better to do the mesh reduction in steps rather than all at once, you know, from 2 million to 200,000, simply because you don't want to overshoot in terms of how much resolution you're going to be sacrificing. So again, if before it took 2 minutes to do, now it's going to be 4 times faster. So half a minute should do the trick. We're already at 36, 7, 8%. There we go. So that's the density of what we want to see, right? So this is how dense the mesh should be, because you want plenty of points to be able to snap to. So let's switch to Arctic mode just to see how, yeah, that looks pretty clean. That looks fine. Okay, back to shaded mode. So I'm going to rotate it correctly, just like that. And I'm going to show you 2 tricks or 2 ways of how you can make this into a proper, you know, semi-proper CAD model. First one is the automatic one, and the second one is the correct one, and it takes much longer. So the automatic one is you select the shape and you just quad remesh it. So you use quad remesh command in Rhino. You define what's the target quad count. I always start with the defaults. I choose the symmetry axis, which in my case would be, I'm looking at this bottom left icon. So the symmetry axis would be Y axis, I believe. So I'm going to tick mark that, and I'll click on preview. I'll click on hide input objects, and usually you do tick on delete input objects, but in this case I know for a fact that I'm going to be remaking the helmet by hand, so that I don't want to delete it. And now basically you just need to wait until it actually creates the quad mesh. It usually doesn't take that long. I'm not sure why it's struggling right now, but yeah, I'm gonna pause the video and then we're gonna see the not final result, but the result of this. Okay, it seems like it's alive, it's doing something. For some reason it took too long. It used to never take this long, but hey. So this is what we get after a quick quad remesh. While the symmetry is way off, Wonder why that is. Anyway, while this does look semi-clean, there are still a lot of problems with the mesh. So let's try to fix those. First of all, the target quad count is too low, so I need to increase this. And the reason why I stutter on the too low part, so I'm increasing it to 5,000. The reason why I'm stuttering on the too low part is because it's too high to manipulate, but too low to get the detail out. And this is why automatic remeshing is a problem. Also, the convert to sub-D, I need to have this tick marked so that that final output is actually sub-D. And let's just see the symmetry. Now it seems like with enough resolution, the symmetry of the helmet is there. But the problem that we're facing now is just the sheer amount of objects or elements that polygons that we have. So manipulating this would be nearly impossible. Okay, let me hit OK. So we have this. Let me just move it to the side like that. Type in show, right? And this is basically after the automatic quad remesh. What kind of helmet do we have? I want it to be in parts and so on, so I would need to start cutting it away, and you can see that some of the polygons, they don't really flow according to the creases of the mesh, so this would be quite difficult to do. If you just need a piece that would be 3D printed, sure, you can do that. Also, in terms of sub-D, you can convert it to NURBS. This might be delete input objects, yes. And that's the strongest thing. That's why I'm showing you the sub-D creation process in Rhino rather than in Blender, right? Because Blender also has subdivision surface modeling. The sheer amount of polygons that this has makes it so that the NURB surface is very heavy, but it still comes in pretty large chunks, pretty large patches that then you later can, optimize and make something with them, right? So that's the automatic workflow. Also, if I were to emap this, environment map, and take a look at it, it's quite seamless, right? So the surface finish is not that bad. I mean, emapping this, well, we see the mesh edges, but it's all jagged, of course, because it's a mesh. Anyway, let me show you the true way of doing it. And the true way is by actually creating a sub-D shape on top of this manually. So how do you do that? Well, you first lock your object in place, like so. Then we can go into options, and for our shaded preview, so options, view, display modes, shaded, open that one up, and I believe it should be under objects. Yeah, locked object usage. There we go, locked object appearance. Objects appear solid? No, we will want them to appear transparent with a certain transparency attached to it, so 50% or something like that. This will help greatly. And also one more thing, let's expand shaded objects, go for meshes, and here where it says edge thickness, let's drop down the edge thickness to 1 pixel, and naked edge settings to 2 pixels. So match edge settings, edge thickness 1 pixel. Hit OK. Now the lines are a little bit thinner, and this is transparent. Okay, so we have the reference setup. Now I'm just going to create a new layer, call it sub-D, like that. Make it, I don't know, blue, tend to use the blue color for this, make it active, and we will create a single sub-D face somewhere on this mesh. So it doesn't really matter where we start. I guess we can, yeah, we can start here on this edge right here. And I'm just going to go for sub-D tools, and I'll just select the 3D face, create a single sub-D face. The command for it is 3D face. You choose that the output is sub-D, and there's nothing really more than you need to do. So let's create our first sub-D face, just like that, right? So after you've done this, you can see that one of the sides of the sub-D is blue for me and the other one is red, and that's because under the display settings, which are right here, I have selected color back faces to be turned on and the back face color to be red. So if I flip my face, it's going to be blue, right? And then the red is going to look inwards. This just helps me to understand what's front facing, what's back facing. Pressing the tab key disables the smooth mode, so we enter the sharp mode, so I can clearly see where the control points of the sub-D are. That's basically it about the sub-D. And now the bit that will take a long time is called append face. Append face. Select meshes or sub-Ds to append to. Select this bad boy. Hit enter. And then it asks me, okay, so what is the face from which you want to, or sorry, how do you want to create additional surfaces on the sub-D? And the way I'm going to do it is by using from edge command right here. From edge, yes. I select the edge and I just click. Let's go for probably here. Click, enter. So every single sub-D face that you make needs to be a quad or a triangle. You can do a triangle as well. But it's very important that you don't do pentagons from the start. Pentagons are a no-go. Also, you want to have as big of a resolution as possible when dealing with sub-Ds, right? So you don't want to make a lot of small polygons, because that's just going to be the same thing. You're gonna have the same problem as with quad remesh, right? Too many polygons. Another rule for sub-D creation is that you can never ever, this is important by the way, so you can never, or you should never, have sub-D faces doing something like this. This point right here would be super problematic, and it would actually be registered as a hole inside of the sub-D, right? So what you want to do in this particular instance, what you want to do is you want your sub-D polygons to always connect corner to corner. You can never have something like this where an edge arrives at another edge, right? Because basically you have points here, right? And every single point of every single polygon needs to connect into this grid, right? So in terms of triangles, as I said, you can also do triangles. You can also do something like that, right? A triangle, a quad, and two quads here. Quad means 4 corners, triangle, well, 3 corners. This kind of setup makes it so that from 2 polygons, like a row of 2 polygons, the triangle terminates, and then you can have a row of 1 polygon. A very helpful kind of pattern setup. Okay, and that's basically, I mean, it's very straightforward. So that's basically the gist of it, of how you topologize the geometry. So I'm going to speed it up, and we're just going to go around here, and you will notice that I will most likely make separate objects, or maybe it's going to be a single object, but I'll decide once I start kind of going through the whole helmet. And I'm only going to be making half of it, as you should as well, because it's symmetrical, so we're just going to mirror it later on. So for now, that this is going to be a bit of a longer time lapse. I would say, yeah, that's like 3 hours of work, maybe a little bit less, maybe 2.5. So let me speed up 2.5 hours for you in like half a minute. It took me 6 hours. But we're here, we're done. We're done with this. Let me show you. So this is a render. It's a very much zoomed in render. Let me zoom out. Like that. I basically used a lot of lights and so on to just check how the surface will behave and how does the light slide over the surface, how do the speculars behave, how is the tiling of the bump map, all that jazz, and everything seems to be a-okay. So in those 6 hours, or 5.5 to be honest, what I've done was create every single patch, right? So parts of the helmet. I've decided on what it actually is. So it's some sort of a VR helmet thing that also has like a mouthpiece here, maybe a fancy microphone, maybe face tracking system. I don't know. But it does look organic. So that's all that matters. And this is still just an exterior shell, of course, a concept for an exterior shell. There's nothing inside. If we hide the lady, you can see that the inside is mostly, a single piece shell. One thing that I kind of went through really quickly in the time lapse that I want to show you right now is how do we make the seams, how do we make it sharper on the corners, on the turns. And to do that, let me just get, actually I'm just going to get one of the elements in here. Let's go for something small. We had a small piece here, yeah, there we go. Let me just copy it to the side and explain what is it that we do to make it sharper. So I'm just going to grab some polygons from here because the form doesn't really matter that much, like that. And also let's just stitch. So stitch, not step 3, stitch. Stitch basically forces two vertices, 2 points, or 2 edges together. And you can select the edges or the vertices with Ctrl-Shift clicking, right? So Ctrl-Shift click to select a point, stitch, to stitch them into one point. That's very useful for cleanup. Okay, so we have this surface here, and what we do with it is first we want to give it, well, not thickness, but we want it to bend downwards, so we extrude it upwards, right? Thus creating this skirt around it. So I'm just going to use an extrude sub D tool, extrude sub D. The default value should be good enough for you. So basis UVN and direction normals, direction N. Meaning that every single face is going to be, or every vertex is going to be extruded according to the normals of that vertex, 90 degrees upwards, right, for that vertex. And then we type in an arbitrary number, some sort of number that we feel like is a good range of thickness, right? So in my case, I do 2 units, right? So we get this plate here, and if I hit tab, you can see that it's, it is bending downwards, but it's still a blobby mess. So we need to sharpen up the corners, and the way you sharpen things and when modeling with sub D is through duplicating the edges, or not even necessarily duplicating, but if you have 2 edges next to each other, they hold the corner much better. I have plenty of other tutorials explaining this in much more detail, so I'm going to kind of skip through this part. So if you just select one of the edges here that you want to sharpen and you type in bevel, make sure that you select segments for the bevel to be set to 1, segments 1, and type in like a smaller number than the extrusion, right? So extrusion was 2, so let's go for 0.2, 10 times smaller, 0.2 for the bevel. And thus it creates this little corner here. Now if I press tab, you can see that the corner is being held much better compared to its friend here that didn't receive the bevel, right? So that's how it works. The problem is that now this is a pentagon, right? Not a quad. So we literally took one corner of this before quad and made it into 2 corners right here. So it's a pentagon, right? That's a no-go, no bueno. Well, technically it can work, but it's much better to protect the quads. So what we do is we undo, and before even we start beveling, we will select all of the top surfaces here, like that, and we're going to inset them. You know about offset, but this is inset, right? And I'm just going to give it like 0.5 inset, like that, and it basically just takes all of the polygons as a group and creates this nice little ribbon around it. Think of it as a negative offset, right? And now, no matter what we do with the corners, bevel, 0.2, no matter what we do with the corners, this surface is going to be protected because that edge that we had here, this edge is eating up the bevel, right? So it's an edge becomes a triangle. Again, bevel, 0.2. So this is what we call protecting your corners, right? With the inset. Very useful little tool. Okay, so basically that is the idea behind it. Sometimes when you extrude things and you bevel things, different pieces of geometry starts intersecting, so you kind of need to scooch things around with the move tool, but generally speaking, the idea is the same for every single piece of the helmet that we had here. Except for the last bit, the foam right here. The foam was made just with lofting, sub-D loft tool. Works exactly as a loft tool, right? So very simple. Okay, so we have ourselves quite an organic looking helmet with, do I still have the render? Yeah. That renders out pretty well. Next steps for it, of course, would be to start thinking about what happens underneath the shell, in between the head and the exterior shell. Are there any proportions that need to be changed, and so on. But that's not something that I'm going to be teaching you right now, because we're already more than 1 hour in, right? This is going to be the end of the video. But if you want this to become like a second part tutorial or something, where I detail this much further, let me know in the comments. If you want this 3D model, consider becoming a Patreon supporter, and you're going to get this 3D model for free, and every single other 3D model that I do in this YouTube channel, for this YouTube channel. I will finish up with showing the NURBS version of this, right? So we were doing all of this because we wanted to have a NURBS version as the final output. And what are the benefits of having it as a NURBS surface? Well, for instance, you can do, this is going to be stupid, but you can do trimming operations, right? So I can just make a sphere very easily, and I can just Boolean difference out with the sphere, or even better, I can trim. I can use the sphere to trim away. Let me go for wireframe view in this case, to trim away areas around that sphere, right? Like that. Let me delete those, and let me show you, shade it, and now this whole part was trimmed away, right? So creating, there we go, creating trims, creating holes, creating like subdividing this whole design even further is easier and better to do. Extracting drawings, I believe I won't even do the make 2D, but extracting drawings is easier, creating sections and so on. All of that is much easier to do with NURBS, and also NURBS geometry does not have a finite resolution compared to mesh geometry, meaning that you can zoom into it as much as you want. And if we were to render out, super zoomed in areas here, it would still render out completely like clean. Like it would be absolutely fine to render out really, really zoomed in. Also, it's always perfectly curved. So it's always curving perfectly. With that being said, there are, of course, inconsistencies in my own modeling. So there's this little bump here that's really annoying me. But besides that, I'm pretty happy with how this turned out. Yeah, that's that. Hope you liked it. I'll see you in the next one. Bye. Bye-bye.